Hi everyone, welcome to my YouTube channel. I am RVS Harshni, studying in Sri Venkateshwara College of Engineering. Today we are going to discuss about control systems. The topic today we are going to discuss on control system based block diagram reduction technique with an example. Introduction to block diagram reduction. Block diagrams are graphical representations of a system's components and their interconnections. The reduction techniques simplifies complex block diagrams for easier analysis and understanding. This presentation will cover the principles of block diagram reduction and provide an example for clarity. The figure shows the block diagram where it contains of G1, G2, G3, which are feedback, clean feedback, and H1, H2, which are feedback path. What is a block diagram? A block diagram consists of blocks representing system elements and arrows depicting signal flow. Each block can represent functions such as transfer functions, gain, or system components. Block diagrams are widely used in control systems and signal processing to illustrate system behavior. Controller, plant, feedback elements, these are the main elements in the block diagram. Importance of block diagram reduction. Reducing block diagrams simplifies the analysis of control systems and makes calculations easier. It aids in identifying system characteristics such as stability and response time more efficiently. A simpler representation allows engineers to focus on key components and their interactions. Basic rules for block diagram reduction. The first rule involves the series connection of blocks where gains can be multiplied. In the series connection, the gains will be multiplied. In parallel connection, the total gain is the sum of individual gains of each block. Feedback loops can be simplified using the formula T is equal to 1 by fraction of G 1 by fraction of G into 1 plus GH, where G is the forward path gain and H is the feedback path gain. Problem statement. An example of problem statement is consider a system with two blocks in series, block 1 with gain G1 and block 2 with gain G2. There is also feedback loop with gain H from the output back to the input. The goal is to reduce the block diagram to a single equivalent transfer function. Problem statement means a statement that discusses what the problem is, why it's a problem in the first place, and how you propose it should be fixed. First step, series block reduction. For blocks in series, multiply their gains to get the total gain. If G1 is equal to 2 and G2 is equal to 3, the total gain G total equal to G1 times G2, that is equal to 2 into 3, that is equal to 6. The equivalent representation for these two blocks in series is simplified to a single block with gain 6. Representation of cascaded control systems. Here, R of S is the input of the block diagram and C of S is the output of the block diagram. G1, G2 are the blocks which are connected in series. In series, the gains are multiplied. The next step is feedback loop reduction. When the series blocks reduce it to a single block, we now address the feedback loop using the formula 1 by fraction of G total into 1 plus G total into H. We can substitute G total is equal to 6. If H equal to 2, then T is equal to 1 6 fraction of 6 by 1 plus 6 times into 2. That is equal to fraction of 6 by 13. Feedback loop reduction is if you consider the diagram G of S where it is the forward path gain, H of S where it is feedback path gain. For positive feedback path, the transfer function is given as G of S by 1 minus G of S into H of S. For negative feedback path, the transfer function is given as G of S into G of S by 1 plus G of S into H of S. Like that, the uh, forward path gain and feedback path gain is reduced into a transfer function. Applications of block diagram reduction. Block diagram reduction is widely used in control system design and analysis. It helps in the design of controllers by simplifying the system representation. Engineers utilize these techniques to ensure robust and efficient system performance. Block diagram reduction is used widely in system analysis to reduce more blocks which are forward path gains and feedback path gains into a single block. Conclusion. Block diagram reduction techniques are essential for simplifying complex systems. Through the example provided, the importance of systematic reduction is highlighted. Understanding these techniques enables engineers to analyze and design more effectively. To know more about the block diagram reduction, there are certain books where you can learn more about block diagram reduction. That is Ogata K. Modern Control Engineering, NICE NS Control Systems Engineering. This presentation format provides an overview of block diagram reduction techniques and a concrete example, making it suitable for educational purposes. Thank you, everyone. Please like, share, and subscribe the video.